There we go. I need a new battery in this thing, I think. Okay, so here's what we're going to do today. 5, 17, 22. We're going to see how to prove that two triangles are similar. Same shape, right? Yesterday we talked about this. So we have 3 ways. There's 3 ways. Okay? Write this down. So there's 3 ways to prove two triangles are similar. One, we learned yesterday, is by angle, angle, sim. We learned that yesterday. If two angles of one triangle are similar or equal to 2 angles of another triangle, then they're similar, okay? We also today are going to have that side, side, side similarity, okay? We saw that in our journal, and we're going to see that. We're going to see that in example 1, okay? And the third way we saw in our journal was our side angle side similarity. And we're going to see that on the back of this worksheet. So we're going to see all 3 of these. Yesterday we saw the angle angle. And then in example 1, we're going to show the side side side. And on the back we'll show the side angle side, okay? Now, side 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 does not mean the sides are equal. Does not. Does not. In fact, they don't look equal, do they? But they just have to have the same ratio. So we need the same ratio. Same ratio is what we need. So I need to find and set up all the ratios. So what I'm going to do first is, I think one of these triangles, I think this triangle got turned around. So angle ABC, that means A goes to D. Oh yes, definitely turned around, isn't it? B goes to E. Oh, it's turned around for sure. And then C goes to F. All right, so I'm going to redraw it because it's kind of backwards. If I redraw this one, it's easier to see. It's a lot easier to see. So I'm going to redraw triangle DEF, and if I redraw it, it makes it a lot easier for me to put things together that goes together, okay? So my E goes here, my F goes here, and my D goes here, okay? Now let me put the numbers back in. So 6 goes there, a 9 goes there, and a 12 goes there, okay? So now it's just easier for me if I redraw it. It really is, because then I can see that it's easier. 8 goes to 6. See, it's easier to line them up. If I remove the triangle, right, so just kind of redo the orientation. So 8 goes to 6, 12 goes to 9, and 16 goes to 12. You guys see it now? And before it's kind of like, well, does that go to that? No, does that? See how confusing it is? But once I redrew it in the same orientation, it gets easy. Okay, so what's our ratios? Let's see. We want to see. So AB needs to go to DE, as BC needs to go to EF, as AC needs to go to DF. And all I'm doing is this. In symbols, I'm saying this side goes to this side, as this side goes to this side, as this side goes to this side, okay? In symbols, that's all I'm doing. I'm saying this side goes to this side goes to this side, and this side goes to this side, okay? Now let's put the numbers in and see if we have the same ratios, right? So we'll put the numbers in. Let's see if we have the same ratios. So AB is 8. DE is 6. BC is 12, as EF is 9, and AC is 16 as DF is 12. Now, if we reduce these, right, let's reduce all my fractions, and hopefully when I reduce all my fractions, we'll get the same ratio. Well, 4 over 3, 4 over 3, 4 over 3. So my ratio is 4 to 3, and they're all the same, aren't they? They're all the same. So are the triangles similar? Yes, 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 yes. We're going to say yes, similar by side, 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 and I just abbreviate. SSS, sim means side, 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 similarity. So if all three ratios are the same, 4/3, 4/3, 4/3, then they have to be similar because they're just a different size of each other, but they're the same shape. How am I doing? Does that make sense? Okay. All right, slide it. Now, in this next example, we're told they're similar, okay? So if they're told they're similar, we can match up things. But I like to make sure, okay, A goes to D. Oh, the orientation is good. B goes to E. All right, good. This is good. Yeah, C goes to F. Okay, good. Perfect. I like to check. Just check. Here's what I did to check. I just knew from here that, you ready? A went to D, B went to E, and C went to F. I think somebody in here yesterday mentioned that they had to be, it was Rayan. Remember Rayan, you said they had to be in the right order. They do. So if that's the case, we do know that the 4 goes to 12, the 8 goes to 3, x plus 1, and the x minus 1 goes to 18, right? Okay. So if I want to solve for x, I would probably set up, probably go this to this equals this to this, right? Check it out. Probably go this to this equals this to this, right? I mean, there's more than one way to do it. There really is. There's many ways to set this up. I'm just going to choose that way. I'm going to go BC to EF as 8 goes to my 3 times x plus 1. And again, there are other ways to set this up. I'm going to go x minus 1 goes to 18 as 8 goes to 3 times x plus 1, okay? Again, there is another way to set this up. That's just one, right? You guys know that, right? There's other ways to do this. I just have to be consistent. Okay, so now I'm going to cross multiply. That times that equals that times that. So I'm going to have a 3 times an x plus 1 times an x minus 1 equals 18 times 8. Oh, I'm going to have to do some math. Oh, I'm going to have to do some good hard math. I like this. So I'm going to have a 3 times, you ready? X squared minus 1x plus 1x minus 1. I'll step back and let you see what I did. What did I do? There's a name for it. What did I just do? Foiled it, right? Okay, I just foiled it. Which is 3 times x squared minus 1, right? Which is a 3x squared minus 3. I have to do some math. I can handle that. Okay, what's 18 times 8? 144. Okay, now I'm running out of room, so I'll put that up here. Okay, I'll put that, what I have right there. I got a 3x squared minus 3 equals 144. Okay, how do I solve? We could. Let's just go plus 3 plus 3. How about plus 3 plus 3? 3x squared equals 147, right? Not yet. Close. Not yet. Let's divide by 3 first, okay? Yes, I agree with you. Who says square root? I agree. Totally agree. We're going to do that. So 147 divided by 3 is 49. And now, Elsa, what'd you say? Square root, and x equals 2 answers, right? X equals 7 plus or minus 7, right? Except for I don't want the negative 7. Nah, negative 7 doesn't make any sense. sense. Show you why. Show you why. Yeah. You can't have negative. You can't. If this were negative 7, then what's that length? You can't have a negative length, right? That doesn't make any sense. Right? If your dad's out there and he's measuring, if you're out there measuring, right, and it's a negative length, go home. If your dad's builder, just go home. You call up the architect and say, hey, you messed up again, huh? That happens a lot. A lot of builders complain about the architect. Okay, turn the page. So x equals 7. What's that? Sure, I can wait for you, Danielle. All right, here we go. On the back side. So on the back side, we're going to look at our side angle side similarity. Okay, we're going to look at that. All right, well, we've got part of it. We have to have the angle. You've got to have one equal set of angles. Got to have that. And I have that. I've got my 100 and my 100, okay? You got to have that. I've got the angle part. So the angle part's done. Thumbs up, equal angles. So that's done. Now what about the two sides? Do they have the same ratio? Well, let's see. 4 goes to 6 as 6 goes to 9, right? Agree? This side goes to this side goes to this side. So 4 goes to 6 as 6 goes to 9. Is that the same ratio? Okay, so we reduce 2/3, 2/3, yes. So are they similar? Yeah, they are similar. So we'll say yes, similar by side angle side similarity. That wasn't too hard, was it? Okay, last but not least. Okay, it tells us the two angles. Oh, I'm ahead of myself. Sorry, my bad. Okay, it tells me they're equal. Now, do you see? I see two triangles. Before I do this, anything on this one, I want to look at two triangles. I see the little triangle, okay? Right? And I see the big triangle, right? Right? So they both share angle A. You guys agree with that? So they definitely have an angle. So I'm going to say definitely angle A is equal to angle A. Now, this entire side here is 30 for the big triangle, right? This side here is 30 for the big triangle, right? Everybody agree with that? And this side right here for the big triangle is 25. Everybody agree with that? So they've got the angle is 12 goes to 30 as 10 goes to 25. 12 goes to 30. Little triangle to big triangle as 10 goes to 25. Little triangle to big triangle. Is that the same ratio? Let's see, I can reduce this by 6 and I get 2/5. I can reduce this by 5 and I get 2/5. So yes, they are similar by the same reason, by my side angle side similarity, okay? Yeah, Reese?
Can you just say since they're parallel, all the angles are equal?
Yes. Yes, that would have been faster, wouldn't it? Is that what you were going to say, Danny?
I was actually going to say, because they're parallel, but you know if there's going to be a ratio between the sides that are the same.
I haven't taught that yet. Yes. That's tomorrow's lesson, Danielle. But yes, okay. Seems obvious, doesn't it? Yeah. Yeah. You're ahead of me, Danielle, by day. Okay. Okay, now last but not least, I got to be careful. R goes to H. That must be H. H must have gotten hole punched out, okay? H got hole punched out. S goes to G, and T goes to K. So they're kind of backwards, aren't they? So that means that this side goes to this side, doesn't it? Right? It's just backwards. And this side goes to this side. I like the colors. Colors are nice, aren't they? And this side goes to this side. So they kind of turned around. One got flipped. You guys see how it got flipped? Right? So if I need to find the value of x, I could go 3 minus x goes to 8 as 3 goes to x plus 7, right? You guys see how to do that? I'm just going to use these values. Take that one with that one and that one with that one, okay? So I'm going to go, okay, 3 minus x goes to 8 as 3 goes to x plus 7. How am I doing? Does that make sense how I set that up? Green to green, purple to purple. Colors are always so nice, aren't they? So if I cross multiply, right, if I cross multiply the 8 comes up, and this comes up, let's see what we're going to have. I'm going to have a x plus 7 times a 3 minus x equals an 8 times 3. Oh, I'm going to have to do some math again. I can handle it. We're smart. Ready to do some hard math? We can do it. We're smart. So I'm going to FOIL. X times 3 is 3x. X times a negative x is a negative x squared. 7 times 3 is 21. And 7 times a negative x is a negative 7x. And that equals 24. I'll step back and let you guys see what I did. I just did my FOIL, right? When, you know, that times that, that times that, that times that, that times that, right? If I simplify this, I'd have a negative x squared minus a 4x plus a 21 equals 24. Okay. This time I'm going to have a factor. I agree. Julia, this is where you're going to have to use your 2 pencils, okay? But before I do that, I don't like the factor with the negative x squared. Harder. Are we done? I want to bring this over here. How do you do that? I want to bring this one over here. It just makes it easier, right? I don't like negative x squared. It's just really hard to do. So we're going to bring that over. How am I going to bring that over? How am I going to bring this over here? How am I going to get this over here? What would I do to bring that over there? Yeah, just add it. So I'll have a positive x squared. Let's bring over the 4x too. Let's bring that over. How would I bring that over? Negative 4x. How am I going to bring that over? Got to bring this over too. How am I going to add that? Add it, right? Yep. Thanks, Ani. Add it. So I get a positive 4x. And then I'm also going to go minus 21, and I'm going to get a positive 3, okay? All right. Well, let's factor. Okay, let's factor. X plus 1 plus 3. You okay with that? Or x is equal to negative 1 and x is equal to negative 3. Well, those work. Well, they both work. They're negative. It kind of makes me nervous. Well, I almost say throw them out. They're negative, right? Let's check this out. Okay, if x are negative 1, I have a 3 minus 1. 4, that'll work, right? If x were negative 1, I have a negative 1 plus 7, 6. I'm going to keep that one. Okay, how about the negative 3? Let's check out the negative 3, okay? Let's see how it works. Check out negative 3. 3 minus negative 3. 6. I'll go with that. And then I'll go negative 3 plus 1 is 4. So there's 2 possible triangles. Weird, isn't that crazy? That'll work. 2 possible different answers. That's a good extra credit problem, huh? So remember that. That might be on a test someday, somewhere. And there they are. Okay? All right. So, all right, we've got a lot to do. We got some homework to do. We've got some teslations to do. I'm going to pass out the homework here in a second. Stop.